Welcome to the Dubai Municipality G+1 exam presentation for civil engineers. Our goal is to simplify the essentials you need to know for the G+1 exam. In this presentation, we will summarize key topics for the Dubai Municipality Building Contracting G+1 exam. We will cover concrete, structural analysis, soil mechanics, materials testing, and local codes, all designed for civil engineers preparing for the G+1 license exam in Dubai. Let's start with formwork and curing. According to Dubai building codes and standard practices, formwork removal and curing are crucial for structural quality and safety. Vertical surfaces such as columns and walls typically require 16 to 24 hours before formwork removal. Slabs should be stripped after 3 days, with props retained for at least 7 days. Footings and mass concrete elements generally require 24 to 48 hours. To prevent segregation during pouring, the maximum free fall height must not exceed 1.5 meters. Additionally, the use of formwork release agents is essential to avoid adhesion between concrete and shuttering surfaces, ensuring smooth removal and surface finish. Next, we delve into concrete properties and mix design. According to Dubai Building Code, structural concrete should reach 35 newtons per square millimeter, and precast elements 40 newtons per square millimeter. Workability is improved with high slump, super plasticizers, and accelerators for early strength. In Dubai's hot climate, accelerators help in cooler months, and retarders prevent quick setting in summer. Sustainable mixes are encouraged. Limit water-cement ratio and include fly ash or silica fume for better durability. In line with Dubai building codes, the minimum concrete cover is 30 mm for superstructures and 75 mm for substructures. This is essential to prevent corrosion of reinforcement in Dubai's harsh climate. Circular columns must have at least 6 bars to maintain structural integrity. Remember, ties help prevent buckling of vertical bars, while stirrups are crucial in resisting shear forces. Poisson's ratio is the ratio of lateral to axial strain in steel under stress, indicating how it deforms, and as per Dubai Building Code, it is considered between 0.25 and 0.33 for reinforcement steel. Understanding beam basics and structural analysis is essential. For simply supported beams, the maximum bending moment is WL²/8, and the maximum shear force is WL². For a cantilever with a point load, max BM/ISPL at the fixed end. The point where the bending moment is 0 is called the point of contraflexure. Fixed beams are statically indeterminate to 3 degrees, while simply supported ones are determinate. Common analysis methods include moment distribution and slope deflection, essential tools under Dubai Building Code compliant design frameworks. Foundation and soil mechanics are vital for stability. Piles transfer loads to the ground. Pile types include end-bearing, friction, and tension. Tests like static load and sonic echo assess capacity and integrity. Minimum pile rebar is 12 mm, and backfill compaction should be 95%. Proctor tests determine optimum moisture for maximum density. Let's take a look at the essential properties of construction materials and how we evaluate them through non-destructive testing, NDT. Concrete typically has a density of 2,200 to 2,500 kg per cubic meter, while steel is around 7,850 kg per cubic meter. Understanding these values is crucial for load calculations and structural design. We then move into NDT methods. The rebound hammer, or Schmidt hammer, helps assess surface hardness and estimate compressive strength. Ultrasonic pulse velocity, UPV, tests the homogeneity of concrete. Good quality concrete typically falls within 3,500 to 4,500 meters per second. Finally, the liquid penetrant test is used to detect surface cracks, especially in metals and welds. These tests allow us to inspect materials without damaging the structure, which is especially useful for quality control and maintenance in the field. Joints and crack control are essential in concrete to prevent structural damage. Expansion joints should be spaced 20–25 meters apart, while contraction joints control shrinkage cracks. Isolation joints separate structural elements, and honeycombing is caused by poor compaction. Now let's discuss post-tensioning as per the Dubai Code. Post-tensioning is a method used in reinforced concrete to enhance its performance, especially in slabs. First, we need to make sure that the minimum slab thickness is 200 mm. This ensures enough concrete cover and anchorage for the tendons. Next, we look at the jacking stress, which is the stress applied when the tendons are tensioned. The Dubai Code limits this to 80% of the ultimate strength, 0.80 fpu, to prevent overstressing the tendon. Then, we have the transfer strength. This is the stress when the tendon force is transferred to the concrete. It should be limited to 70% of fpu, and at that point, the concrete must have gained at least 25 newtons per square millimeter strength to safely handle the stress. Finally, we can't ignore the grout. It's used to bond the tendons and protect against corrosion. It must match the strength of the concrete and must also resist shrinkage, or we risk creating voids and weakening the bond. These values are critical to ensuring safety and durability in post-tension slabs, especially under Dubai's specific construction guidelines. Let's now go over some key highlights from the Dubai Building Code, especially regarding the design life of structures. Dubai classifies building lifespan into 3 categories. 10 years for temporary structures, like site offices or temporary sheds. 50 years as the standard design life for most residential, commercial, and institutional buildings. 100 years is considered monumental, used for iconic or legacy structures that are expected to last generations. In addition to service life, material selection is crucial in Dubai's environment. For marine or coastal environments, the code recommends SRC cement, sulfate-resisting cement, to combat sulfate attacks and chloride penetration. Stainless steel is preferred over regular steel due to its superior corrosion resistance in coastal conditions with high humidity and salt content. These recommendations ensure that buildings not only meet their intended lifespan but also withstand Dubai's challenging climate and environmental exposure. Mastering DIWA and Dubai Municipality standards is essential for civil engineers aiming to succeed in the G+1 exam. Prioritize practical applications, material specifications, structural design principles, and key safety regulations. These notes serve as a quick revision guide to reinforce core concepts, useful for both exam preparation and real-world site work. Thank you for your attention. If you have any questions, feel free to reach out at ziap.hr@gmail.com or visit our website at www.ziap.com.